Hello guys, welcome to Lytical. So today we are going to solve this Olympic question. So after that, we are going to verify whether the answer that we had is correct or not. This is very necessary, and some students find it difficult to verify after solving. So in this video, stick to it. We are going to solve it and verify as well. Exponent x plus 4 exponent x plus another 4 exponent x is equal to 120. So in this case, we are having similar terms here. So we can factorize common terms out. So we can factorize all exponent x out, then to be left with 1 plus 1 plus 1, which is equal to 120. We do this in order to get back our expression back. So now we have 4 exponent x. When you sum up the terms in the bracket, you get 1 plus 1 plus 1 plus 1, which is 3, bracket is equal to 120. So now we can express this as 4 exponent x multiplied by 3, which is equal to 120. Okay, so with this, we can decide to divide both sides by 3. Okay, so we are going to get over 3 over 3. So 3 will cancel out 3, leaving 4 exponent x is equal to 120 on 3. And 120 on 3, we can express it as 4 exponent x is equal to, so 120 on 3 will be 3 multiplied by 40 on 3. Okay? So you can see that 3 times 40 is the same as 120. So we say that 4 exponent x is equal to, so this one will cancel out. So we're going to cancel out the 3, so leaving the 40. So now we have 4 exponent x is equal to 40. From here, we need to introduce a logarithm. So we introduce logarithm. We say that log 4 exponent x is equal to log 40. Okay. And in logarithm, we have log AB. So, okay. So let me say, logarithm, we have log A exponent B, and we can express this as B log A. Okay. So it's a rule and a logarithm. So our expression now becomes x log 4 is equal to log 40. Okay. So let's continue from here. Now we can divide both sides by 4. So with x is equal to log 40 on log 4. So our x is equal to, and we know that log 40, we can express it as log, into bracket, 4 times log 10. So 40 can be expressed as 4 times 10 over, and this 4 we can get 2 squared, which is the same as 4. So we express it as log 2 squared. Okay. So now we recall the rule back again that log A exponent B is equal to B log A. So we apply it here again. So we are going to get x is equal to, so this one the same as log 4 plus log 10 all over 2 log 2. The expression here, we use this rule. We say that log AB the same as log A plus log B. That's how come we had log 4 plus log 10. Okay. So let's continue. Now our x is equal to, so we have this one too. We can also express it as log 2 squared plus log bracket 2 times 5, okay, is 10. 2 times 5 is 10, all on 2 log 2, okay. And here we have log 2 exponent 2, so we can write it as 2 log 2 plus, and this one is the same as this expression, so which is log 2 plus log 5, all on 2 log 2, okay. So in this case, we can say that x is equal to 2 log 2 on 2 log 2 plus then log 2 on 2 log 2 plus log 5 on 2 log 2, like this. So you can see that this one will cancel out, giving us 1. So we are going to get x is equal to 1 plus, here we can say that it's, we can factorize half out. So 1 on 2, you see, dots log 2 on log 2 plus log 5 on 2 log 2, okay. So with this, log 2 on 2 log 2, you can cancel out, okay. This can cancel this. So our x is going to be 1 plus 1 on 2 plus log 5 on 2 log 2, okay. Let's continue from here. So now we can say that x is equal to, we had x is equal to 1 plus 1 on 2 plus log 5 on 2 log 2. Okay, this is what we're having. So now, okay, so now 1 plus 1 on 2, we are getting 3. So plus, here we can say that we can factorize 1 on 2 out. So we get 1 on 2 multiplied by log 5 on log 2, like this. And in logarithms, when we have log a base b, we can rewrite this as log a on log b, like this, okay. So we are going to apply this here. So now our x is going to be 3 plus 1 on 2 multiplied by, we are going to get log 5 base 2, like this, okay. So our s is equal to 3 plus, so we can say that 3 plus log 5 base 2 on 2, okay. So now, so sorry, this was to be 3 on 2, because 1 plus 1 on 2 is 3 on 2, then 3 on 2, here to be 3 on 2, okay. So now we have this expression, so we can rewrite this as 3 plus log 5 base 2 all on 2, because they are having the same denominator, okay. So now we have to check whether the answer that we are having is correct. So let's do the checking. So let's, in our expression from the beginning, we were having 3 multiplying by 4 exponent x, okay, which was equal to 120. So now our x is this. So you get 3 multiplied by 4 exponent 3 plus log 5 base 2 all on 2, which is equal to 120. Okay. But then we can express 4 as 3 multiplied by 2 exponent 2. Okay. So this is 4 to the power 3 plus log 5 base 2 all on 2, which is equal to 120. And in this case, we can cancel this denominator by the exponent of 2. So this can take off this, giving us 3 multiplied by 2 exponent 3 plus log 5 base 2, which is equal to 120. Is the same as a exponent m, okay, multiplying by a exponent n. Okay, so we are going to apply this rule here. So now we have 3 multiplying by 2 exponent 3 multiplied by 2 exponent log 5 base 2, which is equal to 120. Okay. And now we know that 3 multiplied by this here, 2 power 3 is 8 multiplied by 2 to the power log 5 base 2, which is equal to 120. Okay. And also, in logarithm, when you have a to the power log b power a is the same as b. So in this case, 3 multiplied by 8 is the same as. So our b here now is 5. So 5, which is equal to 120. Okay. So 3 times 8 times 5, we get 120, which is equal to 120. So it means that our final answer, which was x is equal to 3 plus log 5 base 2 all on 2 is correct. Thank you, and don't forget to subscribe to our channel for more.